This all changed recently for no good reason. Hey, this is Coffee Compiler Club here today to talk about compilers and language runtimes and I don't know what other things spring to mind, typing systems, and today I'm working on the 1 billion row challenge, so fine. Everything to do with compilers. We're all being recorded live. Everyone here has heard this a dozen times over, except maybe Bobby. And it'll be up on YouTube within a couple hours. Okay, that was into my spiel. If somebody wants to go, otherwise I'll share with 1 billion row challenge.
Yeah, I was curious to hear. Do you have a time yet?
I do, and I'm not done. I have no parallelism. I'm busy breaking it up for parallelism now. So the last time, I want to say yesterday something, I'm probably actually broken right now because and I'm not broken for timing. I'll just do it here. I hadn't put in min and max yet, so actually let me actually time it instead of just run it.
I'm curious, do people start from scratch or do they build off the current fastest solution?
I have no idea. I'm building from scratch. I assume some fraction of people are, in fact, going to build off the current fastest. It's like if someone's going to build off current fastest, it's hard to be motivated to put your best effort forward because someone's just going to clone it and then do, whatever genetic anomaly healing, whatever the hell the thing's called, and
So what's the challenge? So
the 1 billion row challenge. I threw it in Discord a while ago. Here,
Oh.
so I have a 20-second number with no parallelism, and I have 20 cores. Assuming that I'm not just memory bound, bandwidth bound, that says I'll get a 1-second number. The leaderboard as of yesterday was 10 seconds, but my hardware is probably faster than the leaderboard hardware as well. So I mean, I don't know what it's going to turn into.
Not that much faster.
No, it's not that much faster. So I suspect I'll have an easy win, except I'm not doing anything smart. So I don't understand why it would be an easy win. So I'm more suspicious I have a bug than I have an easy win. But it could happen.
I would be very interested in like the difference in performance once you run it on this Hetzner instance. Because you have I remember you have a i9 like Intel.
Yeah.
Just run the current winner on your hardware.
Yeah, that's actually probably easier. Otherwise, I'd have to go get an Amazon account and screw around and make that happen. But like, I'm using the swore thing to go read the city names. I hash them into a table. I, as of this morning, believe I have a perfect hash. I think that's a lie yet. I haven't confirmed it's a perfect hash, but
you need a fallback because like perfect hashes are not. I mean, perfect hashes that don't yield the correct result if there's something that is not inside your hash table will not be accepted. You do a slow path.
I turned off my reprobe logic because I couldn't hit it anymore after I screwed with my hash. I have reprobe logic and it's a closed hash table. I have reprobe logic. It was all working fine. I changed the hash function. Suddenly I can't hit my reprobe logic anymore. I turned it off. I threw an assert in. It's working. I'm highly suspicious. The right answer for turning it into the results is I'll probably out of line the reprobe logic and arrange a convenient fast path that does the right thing. No reprobes ever get hit, but the logic will be there and work. And then if they don't change the data set, I'll never hit it. And that'll be a really cheap test to just blow through. And more or less, it's an inline assert at that point. It just, it's a 1 clock assert check. And I'm just busy otherwise.
The test is a fixed data set. It's not regenerating it each time.
They have an algorithm to generate it. It generates a different set of numbers if you do different city sizes, but I believe it's deterministic at a particular size. It's definitely...
Okay. So it is possible to pick a random number in your hash function that happens to have no collisions so that it's faster.
Right. There's a list of 413 cities it's going to pick from. And how many bits of those cities do you need to read before you get unique? Well, it turns out it's more than 8. So all those people that grab the first 8 bytes with a misaligned load will fail on Alexandria versus Alexander or something. There's a couple cities that say stupid things in their name. City of blah, blah, blah. And suddenly you're tied with all the other city of blah, blah, blahs. And So you have to read more than 8-bit bytes to get unique at all. And then I did an obvious stupid thing and suddenly, you know, the reprobe says, yeah, you're perfect. So fine. So if I am, that might be part of it. It definitely looking good. So are you here? No. Oh, waiting. Yes, I'm here. That's why I didn't come on instantly. It's because I was screwing around. I just put in min and max, and I have to fix my bugs with min and max, and then I'll go back to parallelization. But I got the parallel parse working on 2 independent single-threaded chunks, so I'm pretty sure it'll work on independent chunks, and then I'll actually run them in parallel. And maybe I will get a 2-second timer. That would be nice. All right, that was my share on, you know, Billion Row Challenge. I'm gonna pick on Yorick in a minute because I know he was making progress with incremental things, and he's still setting up.
There's something very interesting I found. I don't know if perhaps my code is wrong, but I was doing some like micro benchmarking for these streaming loads on AMD, and I noticed that, let's say I want to have 4 gigabyte or a 16 gigabyte, like just a huge file, but it's in RAM, and I want to just go through it and look for something, maybe either like something or search for a character. The interesting thing is when I do a tiled load, where when I do basically, I have an unrolled loop, and in there are 4 loads. 2 are streaming and 2 are conventional, like temporal loads. When I have both of them in an unrolled loop and the streaming loads are offset by a large amount, then for some reason I get much more throughput. It's a really weird behavior
Sounds
that
like
I have
you've
not.
got a prefetch triggered going.
The thing is, like, the prefetcher is participating, like, or is acting under the same rules as normal loads. Like, it still like will limit my bandwidth. So I don't know what's going on. And the thing is, if all 4 of these loads are either temporal or non-temporal, that effect doesn't happen. So it's funny only when there's a mix. So I will have a like I will try to understand this a bit better, because it can have help in such a challenge where you're maybe wanting to go through a file and you want to parallelize, and then this tiling, like if you're aggregating some kind of result, like doing a reduction or something, then yeah, maybe
So
this
do you
can
think
help.
you're confusing some branch predictor or something?
No, there shouldn't be any branch going on at all. I mean, this is like a small loop. There should be like the
Right.
branch predictor should actually be powered off in effect. So this should be
Should just
like,
be prefetching. I don't know. You know, x86 prefetch always got complicated. I quit worrying about it years ago. There were like
Yep.
limits of the count of streams. You know what you can do? You can trick it into starting 2 independent streams. I wonder if that's what's going on. The prefetcher looks at all the loads that are running by, or the memory ops running by, and decides he's seeing sequential loads happening. And then he issues 1 prefetch stream for each independent set of loads that he sees that are marching at some particular known frequency and offset and whatever. If you offset your 2 guys, then you get 2 prefetch streams running in parallel. And I don't know if that's the answer or not, but that would say that you would only go to temporal or only non-temporal and spread them out. And it's the spread out that's important and not the temporal, non-temporal mix.
yeah, that's the weird thing, right? But like I would have expected then, like if that were the case, then it should like this effect should happen when I have, for instance, only temporal loads.
Oh, is this
And I
only
just
AMD?
Yeah, I only tested on AMD. And the thing is, like, I suspect actually that non-temporal loads and temporal loads, they use different parts of the, like,
Yeah.
I don't know, that their load architecture, they have maybe separate buffers,
Yeah.
and maybe there's some capacity that is unused if you go only like
Right.
if you only
Now
use
I'm
one of
thinking
them.
that's correct. That sounds much
But
more plausible. They probably
honestly, yeah, but yeah.
have intentionally shortcuts for the non-temporals that cheat on cache hierarchy and the like.
Right. There definitely is some,
Yeah.
right. You don't need to tag some cache lines with some metadata or something.
Right,
So,
right, right. So you cut a lot of hardware and have a much simpler path for it. Yeah, that makes sense.
But honestly, last time I mixed up Intel and AT&T syntax, so I don't have much confidence that I that I am like 100% like error proof in my implementation. So
Oh, yes, that's the other one I haven't done. I haven't sorted out all my final
When you
answers
stagger
versus the
them, do you
old
get them
final
onto
answers.
different cache lines, such as to avoid any kind of Spectre meltdown protection?
You got a chip that's got Spectre meltdown protection on?
I definitely have mitigations on. I don't know. That could have. That could actually be. That's a good point. I should probably turn mitigations all off.
Yeah.
Right.
Yeah.
Yeah. Actually, I understand. Only have very poor understanding of these mitigations. Like on Intel, they're very well documented. On AMD, I sometimes have trouble. But yeah, that's actually a good point.
Where did? Oh, not. Okay. Okay. Wow. So, where did York? Are you able to share on what you ended up doing with your caching of .os?
Yeah, sure. Can you hear me properly?
You're fuzzy. It's very odd.
Charlie Brown teacher fuzzy.
Better now?
It's
No.
like your microphone
Nope.
has a broken bad cable connection. You don't worry about it if it's just not going to work.
It sounds really funny.
Yeah. Or a broken speaker, like a torn
Better
speaker.
now?
It's
Yeah.
not coming through the microphone. It's not your microphone. It's something else.
I think
Because
this
there's-
should work now.
Yeah.
That worked.
Works.
Oh, you must have another
It's set to
microphone.
the wrong like USB device
That's
reasons.
fine. Yeah.
Yeah, caching. So the sort of backstory there is I was working on incremental compilation, specifically at the object file level, meaning that most of my compiler just runs from scratch every time, do type checking, all that sort of thing, and then when it's time to lower to LVM and compile object files, that's where it decides, hey, have we already done that? If so, can we reuse that? The idea being that LVM takes up 85% of the time, so that's where it's the most beneficial. And for the most part, I have that working in the sense that, it does it invalidates the caches as needed, etc. And it in the single-threaded case, yeah, the improvement is basically 85% in the best case, because in the best case, LVM doesn't have to do anything. Like all the object files already exist. And then if you flush a few of the caches, it's obviously a little less, but still pretty good. Interesting enough, with the parallel compilation enabled, the benefit is much smaller. So on my desktop, for example, I have 6 cores, 12 threads, and with 12 threads, there is a improvement of 2 times, but we go from something like 600-700 milliseconds to like 300-350. So it's basically, it's fast versus it's slightly faster. And like in terms of, do people perceive the difference? The answer is basically no, you don't. So of course a bigger story if you go from, let's say, 4 seconds to 1. But I found that because the code generation process is embarrassingly parallel, there's no data shared basically between the modules, because I set it up that way. It will essentially scale linearly as your core count goes up. And so, yes, on like on my laptop, for example, which has 4 cores, 8 threads, the difference is a bit more noticeable, but again, we're talking 100-200 milliseconds at most. And this is all taking and one thing that is still happening is that the LVM IR that I'm producing is just god awful. Like it's the worst of the worst. Which means that if I further improve that, combined with parallel compilation, the benefits of incremental compilation start to diminish a bit. Now, I'm not saying it's useless. Like it's very useful, especially if like, you know, really big project, like let's say 500,000 lines of code, things like that. But there's a couple other things I'm already doing that kind of help in that sense. Like I don't have any compile time code execution, like no macros, no like actual code evaluation, nothing. And I intend to keep it that way. And similarly, when I specialize types, I don't just specialize functions and types for every single instance. I group them together. And I specialize over those groups, which means that there's going to be far fewer copies of the same types, functions, etc. And that's all deliberate, so that compile times are sort of better balanced with execution time, instead of what you see a lot of languages do. They just full on focus on runtime performance, even if that means compiling the code takes forever. Go being a noticeable exception. But so now the problem I ran into today is there's two problems. One, annoyingly, I realized, hey, this will be a problem, but I've not been able to reliably trigger it as showcasing, hey, this actually is a problem and my fix works. And there's some other problem where I haven't quite figured out what's going on. But basically what happens is I compiled the test of my standard library without a cache. So I produce all the object files. You run it, works fine. I then change one test so that it basically creates a new array of some random type I picked. It will recompile that one as expected. You run it again, it will crash. And the first problem I identified there is that the way I do dynamic dispatch is essentially using almost perfect hashing. Basically, at compile time, the compiler generates hashes, and it generates them such that for every method with the same name, they get the same hash. So push always has, let's say, hash 42. But that's fine because I don't allow overloading. So within a type, the hash codes are always unique. And then the dispatch site is compiled to, in the best case, essentially the equivalent of that hash code, which is known as compile time. Bitwise and the number of methods -1. And that is then used to do essentially a virtual call through a method table.
And your hashes are unique.
Yes. And my hashing approach basically FMV1A, and then if it encounters a collision with two different values hashed to the same hash code, it basically starts injecting an incremental number that starts at 1, 2, it keeps trying until it finds a unique hash, which in the worst case can take forever, but I've not seen a case where it actually happens. Like it's a 64 bits hash, and even FMV, even though FMV is not the best, the chances of collisions are small enough that this works okay.
I can tell you about
tested
chance of collisions on 64-bit keys in a little while here. I have a war story for that one, but
right. Also, so the problem here with these hashing is if a collision is possible, the compiler inserts a probing loop.
okay, right.
And from what I've seen, in most cases you get maybe 2-3 probes at most.
Yeah. Sure.
So it's still plenty fast.
Not even that much, but fine, right?
The problem with incremental caching is then what happens is you can compile a module to an object file, and it has some dynamic dispatch call site. When that was first compiled, there were no collisions, so it compiles it without a probing loop. Then at some point you add some new module that's completely irrelevant, and it creates an instance of a type that implements the trait at that dynamic dispatch call site. What can happen is that the presence of the new type may introduce a collision at that call site. Mm-hmm. So you'd have to recompile that object file. My compiler didn't do that. And so when I realized, I was like, okay, the fact that this works is probably coincidence, but this will break. Like there will be times where it either calls the wrong method or it tries to call a method that doesn't exist.
Yeah.
So that's one problem. And then I realized sort of there's a sub problem where in theory, if the order in which hashes are generated changes, they may produce different values if there are conflicts.
Yeah.
Like I had a dump of all the codes, and if there are no conflicts, the codes are the same.
Yeah.
But if if I
Somebody
have
gets to the
hash
plus
A
one.
and so if I have
First.
input A and B,
Yeah.
and I process them as A and B and they collide, A will basically get hash +1 and B will get hash +2. But if I flip them around, it's different.
Yep.
The second problem I haven't quite figured out, because I had some sort of mitigations for this, where I basically said, okay, let's, for the sake of figuring out what's going on, let's say we always compile the probing loop. And I did some checks to see, hey, are there any hash collisions? No. But then it still fails to compile. And so I'm guessing there's some other stuff going on where it's sensitive to ordering and things like that.
Right.
So I tried to like slap some sorts in the right places, didn't fix it. Did some further debugging where I found that if I have everything cached and I compile it like 5 times, 3 times it will be producing the same results. Then 2 times it will say, hey, we have this collision. And I'm like, huh? And so that's where something is changing in order sort of randomly.
You're running concurrent compiles, right?
No, so this is all with one thread. Like I was smart enough to realize let's disable
now
that.
it's weird. Yeah.
But so basically it seems that certain things are processed in an order that isn't necessarily guaranteed.
Yeah, and where's the randomness come from?
It's probably that ordering where something changed. I haven't quite figured out why it sometimes says, hey, this thing collides, sometimes it doesn't.
Right.
But so there's something going on there.
I hunted down all sources of randomness and killed them a long time ago.
Right. And so this eventually what this led to is me thinking like, okay, let's take a step back. Right. Incremental compilation at the surface level makes perfect sense. Great feature to have. But does it make sense in this case? Because one, I already have parallel compilation that I think that gave me like a 4 or 5x speed up on average.
Well, you reported it 2x a minute ago.
No, that's if you have incremental on top of parallel.
Oh, I see.
And of course, the parallel improvement, it depends a bit on like how many modules there to compile. I can probably do some clever things there to like split things up into smaller modules to take benefit of more cores. But anyway, basically came down to, okay, the impact is significant when you do one thread, but it kind of starts to get slower the more threads you have.
Now, you'd like to have incremental too.
Right, and that poses the question like, hey, we have this incremental scheme. It's very sensitive to the order in which things are processed. Certain variables, inlining may affect it. So if I inline a function and the source code changes, I now have to change my module that it's inlined in, and potentially many others. Right, so there's
C2 doing dependency tracking on all these things. I mean,
right. So I have that too, but basically what I end up with is this state where certain small changes that seem unrelated can trigger this sort of cascade of cache flushes to a point where I'm like, okay, I suspect that's going to happen quite often. Is it at that point not better to just not do incremental compilation?
No, it's better to sort out why you depend and refine it over time. So you get this cascade, but I bet you with some amount of work, you can slowly, keep your correctness, but whittle down the cascading effects so you don't have to recompile everybody for stupid things.
Right.
How do you solve the cascade of needing to recompile for the parallel compile?
No, so the need to compile is independent for how it's done. Somebody looks and says, I need to compile because blah, blah, blah. Now I have a set of compile jobs to go do. They're parallel. Okay, they are. Now, if separately you're saying, how come I run the compiles in parallel and that causes different things to be cached or not cached differently in the future? That's a source of randomness because your compiles happen in a random order, and you need to, hunt that down and kill it.
Yeah, so I spent some time trying to figure out, is this an ordering thing, whatever. I think for me at this point, the thought process that sort of happened was like, okay, even if I sort out that randomness, I still have to cover this case where changing one module may require recompiling other modules because they use dynamic dispatch. And then I thought, okay, what if I cache things at a slightly higher level where that ordering doesn't matter? For example, in my mid-level AR, where most optimizations happen, it doesn't care about any of these hash codes. It just says, this is a dynamic dispatch call. That's it. And so in theory, I could cache there, and then it doesn't really matter in what order I process because all of that hashing is sort of done afterwards.
Well, your hashing still sounds suspicious, though, because you're out in the you can't do the +1. You have to do the reprobe loop. The +1 sounds suspicious. Sorry.
So the +1 only happens if
question.
two different inputs produce the same hash code.
Yeah, but the low frequency doesn't mean no frequency, and then that's a and it's
Right,
an
right.
error.
And so
Wait,
that
wait,
+1 that is
let's look at
ordering
Theodore.
sensitive.
One quick question. The reprobing is happening at runtime when it's encountered, or it's probing if there is a collision. If there is a collision at compile time, it tries to incrementally add the
No,
number.
so the hash codes, they're generated at compile time.
Okay.
That +1 is to account for the case where, I don't know, kittens and mittens produces the same hash code.
Okay, but when do you probe it? That was my
The
question.
probing loop is generated at compile time, and so it runs at runtime. It's equivalent to your standard hashing loop, where you loop and then if x bit and whatever equals the hash, okay, break. Otherwise, index +1.
Okay.
And so the idea I had is if I cache things, if one, I basically give LLVM as little code as possible, like I already have most of it optimized, etc., so that when it runs, it doesn't run as slowly. And I then cache my work. All this sort of ordering stuff happens afterwards. So then it doesn't matter that the order changes because all of the slow work I've already done and is order independent. But in its current state, everything before that is or at least fast enough that it doesn't really benefit from caching. It will benefit much more from me just making it faster and being less stupid about allocations and things like that. So that's where I now basically have to decide, like, okay, do I want to potentially spend another week trying to chase out these randomness things and bugs and whatever? Or am I just going to say, look, this is going to be a problem for Yorick 5 years from now, when the compiler probably has changed substantially anyway, that the state of everything is probably quite different.
Oracle deal, yeah.
But it's happening at a critical stage, and so yeah, I don't know.
Well, so that's the thing with parallel compilation. Compile times are actually pretty good in terms of what they were before. Like, so my standard library, if I compile it with, I think, what was it again? I had it noted down. If I do, where was it? So that's incremental. Yeah, so with 4 cores, 8 threads, the parallel compiler on my laptop, so that's a laptop, which is not very good for measuring, the speed up was 4x. On my desktop, which is 6 cores, 12 threads, it's somewhere between 4 and 6. It kind of varies per run a bit. So it seems to roughly scale linear with the number of physical cores that you have. Probably because I'm saturating something such that hyperthreading isn't as beneficial.
Caching.
For smaller projects, it's a bit more significant. Kind of also depends on how terrible the code that's generated. Like what I have now is I can print the time spent per individual module. And what I see there is that some will take like 2 milliseconds, other will take like 100. So it's very dependent on how terrible the code is that I'm feeding it. And I saw that if I enable LLVM optimizations, the time went from 16 seconds to 4. So that's again like 4 or 5x. On my desktop, if I run it quickly, so with one thread, no incremental compilation, it takes about 2.1 seconds. If I do 12 threads, no incremental compilation, it's 530 milliseconds. So if I do enable incremental compilation, it's roughly the same amount of time because it has so many threads, it just blasts through it.
I would say at this stage, there's
Sorry, I'm sorry. That's the first time. If I then rerun it, so it has all the caches, in theory has to do nothing, then it's about 230 milliseconds. Yeah, so twice as fast. But we're talking about half a second versus a quarter second. It's like people are not going to notice that.
Right.
But they are going to notice when the code doesn't
I think
run.
they will. They won't notice going from 500 to 250, but they'll notice going from 250 to 500. I guarantee that.
Oh, yeah, that's true.
I don't know. It's more like they will notice, maybe not, but they will definitely notice the binary not working because it's compiled incorrectly.
Yes, it's more important to get correct, and you probably don't have such a large corpus.
Right, and right now I don't have any programs that are like 500,000 lines of code.
Right.
So it's difficult to really figure, okay, is this going to matter in the next 5 to 10 years?
Right. You're beating you're beating the dead horse or whatever. It's too long. Stop it and move on.
Right. That's where I'm now at. I'm now considering like, okay, it's a bit annoying because as part of the funding I get, I had incremental compilation planned. So I now have to convince these people like, hey, I did parallel compilation instead. Give me the money anyway. That will probably be fine. But that's where probably what I'm going to do is basically let it simmer overnight. And then over the weekend, I will make a decision that most likely I will just keep this in a separate branch for like future references, but probably will plug in some improvements. Like I change how object file names are generated and stuff like that. But I currently leaning towards that I'm going to leave incremental compilation to be a future problem.
Why not make it an experimental, like something you can trigger with the command line option, so you can still kind of mainline it, but not have it on by default?
That is an option. Currently, I have sort of the opposite. Like it's enabled by default. There's a flag to disable.
So that when you said that's an option, that wasn't a pun.
No. I mean, it's an option, and it's also an option. I think the issue there is then you either have to commit to making sure that your compiler changes are sort of compatible with incremental compilation, which means sort of continuously you have to make sure like, oh wait, if people enable incremental compilation, we need to make sure that this runs in a, say, stable order, etc. Because if you don't, what's going to happen is, say a year from now, somebody's going to try and enable incremental compilation and like nothing works because nobody took it into account.
For C2, incremental compilation tracking was fairly invasive. It was not a thing you could fire and forget and then have it maintained. It would have bit rot fast.
Right, and so there's a simple case there. Initially I was like, at some point I realized like, oh wait, if my version changes of my compiler, I probably have to recompile the caches because I don't have a stable ABI. So I generate this file with the version number, and if it changes, recompile. And then I realized like, hey, wait a minute, during development, I'm making a lot of code changes, but the version stays the same because I haven't released it yet. So how do we make sure that it then takes that into account? And what I ended up doing there is I basically say, if the compiler executable is newer than the object files, flush them.
Yeah, okay.
And that's already where it starts, where now you have to track that. You have to account for the fact that theoretically, you are not able to obtain the path to the current executable, which means you also can't figure out what time it was compiled at.
No.
Which means that
number in.
Right, so you end up with all these little things like, oh, we have to do this, we have to treat that. Oh, if this variable changes, we have to recompile. And I think that works fine if you have a stable compiler on a sort of stable language. Much of the problems have already been sort of beaten out. And then you can say, hey, how do we build incremental compilation on top of that? But many of these things I'm still figuring out. I don't have optimization passes yet. I don't know how those are going to impact flushing caches of incremental compilation, for example.
So put the hash of the code in the object files and the hash of every object file that is a dependency in the object file, and turn your entire build pipeline into a giant Merkle tree.
Essentially, that's what I have. I store hashes per object file. I experimented with to handle these dynamic dispatch call side changes. To what I initially did is I tracked like, hey, if in this module there are any classes for which there are collisions, we sort of, those booleans are hashed into the hash. So that if those change, the hash changes and thus the object file is updated.
Yes.
But then I realized, hey, that's actually the opposite of what I want. Because the problem I have is some module that calls a method through an interface. But that module doesn't necessarily have to define the possible classes. They can occur somewhere else. So what you really need to track is per module, the methods that are called through dynamic dispatch. Then you need to figure out, can those possibly collide? Hash all of that into your hash. And then theoretically that would work. But then you get that cascade of flushes where like I instantiate some new type and now 15 modules are recompiled because maybe there is a collision. So that's my TED talk.
Right. And you see too, basically tracked a sort of hand-rolled in-memory database that had everybody that ever got inlined and everybody who I asked questions about, like, how many subclasses do you have? So you have only one, then I can shortcut, or you have two and I put in an if then else instance of breakdown. And were you ever a null, and were you this, and were you that? And it got semi-complicated. Then whenever a class got installed, the debug info was checked by the class loader against all C2 classes to see if any of them would blow up. So the database of info was indexed two ways, depending whether you were adding a new compile job or you were trying to hook a particular piece of the class hierarchy such that if it changed, you're going to go recompile things. Like I said, it was kind of invasive.
But at least Yorick's world is closed. In AA, you're going to have an eval that at any time could go and validate chunks of your compilation.
Same as Java, right? Class for name. There you go.
Yeah, same as Java.
So I'm saying, so yeah, I mean, it's solvable, but I wouldn't claim I would say it's invasive. And if you're going to do it, you have to do it all the time and maintain it. And then if you're not, then don't do it. And just recompile in parallel instead of incremental.
But if you want to have any kind of reasonable eval in your language, don't you have to deal with that?
Well, if you're gonna, oh yeah, sure. I mean, if you're jitting and evaling, then I think, yeah, you gotta deal. If you're Python, you're not jitting, so it's okay. No, you're right. As soon as you touch an eval in, all your closed world assumptions go away, and now it's either rebuild from scratch or you need that incremental database to track what to recompile. Sure enough. All right, what else?
Next topic.
Yasser, you want to share where you're at?
You're muted.
He unmuted, but I got no sound.
Yeah.
Can you hear me now?
Yeah, that works.
Okay. Yeah. In terms of things, I'm layers deep into adding stuff and trying to write documentation. And then the other thing that I ran into
There's your problem.
Yeah. The other thing I ran into was I was trying to, so my goal was like, I've got this code generator stuff that I refactored to ideally be a little easier to work with. So the idea would be like, if you wanted to add a new target, you would go in, you'd add some file, and you'd hook a bunch of constraints together, and then that would like notify what the register allocator needs to do, and then you'd hook what the the different like sort of tiles look like, and then you'd hook those to some machine code post register allocation, and poof, you'd end up with machine code. The issue I ran into was when documenting that I'm like testing with MIPS, and MIPS doesn't have certain instructions. And so while I'm doing that, what I ran into was I wanted to perform certain optimizations because I realized I missed them. and they wouldn't matter as much in x86 because x86 just doesn't care. But they would matter on MIPS, as in like I have like a random like sign extension. Sign extension, I'm like shifting down and then shifting back up, or no, shifting. Wait.
Well,
Where
up
to-
and back down if you're trying to sign extend. Yeah.
Yeah.
Whatever.
Yeah, and so like that's a lot like simpler of a pattern in x86, and so what I realized is, oh, I forgot to do like loop induction like optimizations actually, and so that's what I've been figuring out right now actually.
Wait, how'd you get from shifting to loop induction optimization?
Because I didn't like the sign extend happened in a loop, and the idea was like it was the iterator. The iterator was always being sign extended in every iteration of the loop. Might as well just like extend the like the induction variable. It's like that would save on all of the sign extensions. It would actually just kill it because the value itself is.
Somebody's
well, no, actually, the
marching
value
up.
itself could need to get extended before the loop starts.
Somebody's marching a bit through a bit mask and it's signed, so you're sign extending the bit as you march it through.
Yeah.
Something like that.
Yeah, and so I want to hoist that, and so the idea is going to be like, oh, figure out what users the loop actually has, and then from there, I don't know, figure out some sort of like frequency cost analysis thing, and say this is probably the best one to pick.
I did a lot of that kind of stuff with peoples as well.
Yeah, that's one of the things I noticed. If I have a loop and I know that like it's like I've got some sort of like loop node, I know that it's like counted loop.
Yeah.
I also know that the region basically has like a proper back edge and then like a body.
Yeah.
And I can also see, for instance, if I have a phi node and the phi node is like, oh, phi to like an addition and then back to the phi, then I've got like this cycle there, and it's like, okay, with those two facts, I can mostly like do some of these optimizations in peoples actually.
So I did. It sounds like you had the right thing there. I did changing the node types out once I knew something. If a region was part of a loop, I'd change it to a loop node, which inherited from region, but had all these extra accessors that gave you the parts of the loop. And then counted loop went off of a loop node and gave you all the induction variable and the stride and the upper and lower and mid, blah, 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 all these things just on accessor functions.
Yeah.
You could walk through the loop then looking at fees and ask that they were not the induction variable, but they were counted, strided by whatever, and therefore they were just a constant offset from the induction variables, the common case. So you could just throw out the second extra induction variables and just use the offset from the main one. There's all that kind of stuff's all peoples once you know you got a counted loop.
Yeah, whatever gets me to remove this nasty looking pattern of like sign extensions, because in x86 I could say like, oh, I've got like I could stick so many things together in x86. I can stick like a sign extend onto like a load with like some like strided access with an offset, all into like one operation.
Yeah. Well, the other thing is, while chasing down X, you found Y, and then you chased down Y because it was stupid, and you found Z, and then you
this is why I'm so many layers deep into like rewrites.
So the question,
Yasser, half a rewrite. Yep.
The question, Yasser, is when you put all those together into a single x86 op, does it then translate it into the same 14 original microcodes?
That's the x86's problem.
Yeah.
Getting faster is the point.
Oh, again, I claim that's the x86's problem. Almost always it's faster.
But it is sort of there is something sort of funny about that, which is that like Intel itself is like a hardware company, and so like they just make hardware that like tries to be fast for whatever like software people figure out, and like software people do a lot of weird things, and so there's a bunch of weird hardware, but like it's never like, oh, let's like, I don't think Intel could get away with being like, oh, let's make like the processor significantly dumber, but like if you know how to use it, you know.
Oh, I think that's true of many of their chips.
I think their chips have just gotten like really, really like heavy-handed.
Yes, but there were definitely years upon years where they had a high-end version and a low-end version. And the low-end version bailed out to whatever, BIOS, microcode, whatever. And the high-end version had dedicated silicon.
Yeah.
And so
I think the best example for me is probably like Itanium, but Itanium kind of failed, which is unfortunate. Because it's one of those like,
I did the Java port to Itanium.
Yeah.
Fine.
Yeah, no, but it's like it was the closest attempt to. Wait, what?
Sorry, Cameron. What?
I was asking if you actually liked Titanium.
Did you use one? Me or Yasser?
Or likes it.
Wait, which one of us likes it?
Don't matter.
Am I not coming through clearly?
You are, but well, maybe. Okay, sir, I'll go. I coded for it. It was difficult, obnoxious, and had huge amounts of hardware support for things that you would never do in Java, like rotating register file, for example. Led for giant, bulky opcodes, especially the first 1 or 2 versions. You couldn't pack instructions so well, and so there were huge counts of fat instructions that were mostly no ops. They have 1 op, and then you must have done 2 more no ops, and you couldn't do anything else, and then you had another one. So that the code bloat was like horrendous. And of course, Java, it's like twisty C code. There's all kinds of little bit fiddly jumps everywhere. It did not pack well on Itanium, which is totally geared for like high-end scientific computing.
Yeah, I was going to say it seemed like the ideal architecture for Fortran, and that's about it.
And that's about it. Yes, you could do high performance numeric C in it too. So there is a numeric C thing, but other than that, yes. Other than that, geez. And there were a lot of cool papers that came out that said an infinite register machine with infinite wide issue could run infinitely fast in theory, and in practice, it sucked badly. And it sat under my desk at Sun and was an enormous space heater of hugely loud.
Kept your feet warm though. Your
feet
never got
yes,
cold.
In the middle of summer in San Jose. Thank you very much for keeping my feet warm.
To bring it to where I am, it's cold here.
Yes, we'll park it outside and heat the universe. It's all good. We'll melt the ice pack or whatever, melt the Arctic. Yep. What a thing. It had an okay instruction set, kind of, except for the bin packing of instruction ops was no good. I claim Azul did a much better job of having an instruction set that would pack things together nicely. I guess it was geared for Java, though. It would pack things together nicely. But it would have done fine for Fortran crap, too. I don't know. I think Itanium was not one of Intel's better ideas. Fine. Yeah, so did you ever have to code for the Itanium, or is that not on your list?
No, I'm too young for that.
But you're doing MIPS, which is not a young chip.
Well, yeah, but like there's a bunch more like MIPS resources than there are Itanium. I tried to buy like a used like Itanium box at some point, but like I don't really want to at this point.
No, you don't.
Yeah.
Unless you live in Maine or Minnesota or whatever, and you need a foot warmer, a highly inefficient heater.
Yeah.
And people still make MIPS chips.
Really? Oh, that I didn't know. Really?
I mean, like the
Embedded.
Georgia Tech lithography class, you make a MIPS chip.
Really? Okay, fine. It was a sane architecture. I think I coded
You're
to
like
it
65,000 transistors and you've got an actual 16-bit chip. It's crazy.
Right. Something reasonable. I think I coded to a MIPS chip in grad school as one of my compiler courses.
I think they're still sold for embedded use, aren't they?
Yeah, okay.
Isn't like the Chinese Longsun chip more or less a MIPS?
Yeah, I think
further
Shaw
evolved?
mentioned that actually.
Chinese have all kinds of clones for everything.
Yeah, it's like MIPS with extra stuff, but it's like I think it's MIPS enough. And then apparently it's got things for doing like x86 and ARM emulation, but I don't know what that means actually. I've just heard people say that before.
The thing is, years ago, the transistors used to be large enough that you could actually reverse engineer a chip manually just by looking at it. So that was Gene's first job in software, actually, or out of college, I think, was reverse engineering Intel or no, what was in the PDP? That wasn't Intel.
Is it in Russia?
Back in the good old Soviet Union.
Yeah, right. Okay.
Wait, sorry, who's
I
G?
take it the PDP was not in the 8086.
No.
I coded those too.
It was
Gene's a friend of ours at XTC. He's an old Russian guy, been in the US. I don't know how long he's been in the US.
30 years.
Yeah, okay. Well, that's a good war story though.
Yeah, so what happened though is as things got miniaturized, they could no longer just look through a microscope and reverse engineer it. So that's actually what killed the Russian chip industry. Because they went from being 2 or 3 years behind to being, 20.
Wow. Oh, I have my 64-bit hash collision, which I guess is not fair. I have a 32-bit hash collision. I'm grad school. I'm hacking up the brand new C++. I'm trying to write a little optimizer. I need a fucking dictionary. This is pre-SDK, so I wrote a hash table using 16 bits, and at some point I threw a hack in there to say, do key compare using whatever 16-bit size of the key compare using a subtract, and branch if 0 or not. And then later I went ahead and cast it up to 32 bits because, hey, that's, now it's a 32-bit table, and I brought it with me to Sun. And the first cut of C2 was in fact mostly doing 16-bit stuff for the nodes. We moved to 32 pretty quick. Somebody later moved it to 64. And then the hash compare function was still using a 32-bit subtract to compare hashes. And sure enough, at some point down the road, a rare crash kept appearing that was some particular codes would collide in the value numbering table on 64 bits, compare on 32, decide they were the same value number, do a common sub-expression on two unrelated things, and you get crap code and die. And that bug lived in that code 20 years. And, the bug fix came around like 5 years ago. Somebody asked me about it, and we're like trying to sort out what the hell. And I was like, oh yeah, that's true. And then there it is. So it was a 20-year bug. But I guess it was a 64-bit collision. So there you go, Yorick. It can happen across all of Java's executions for 20 years.
What's weird is it was a collision on 64-bit hash code, and then a collision on a 32-bit key comparison. So the likelihood of that is pretty small, right?
Well, the hash got mapped down to the size of the table, so it wasn't the whole table size that collided. And
Was it a key comparison?
The key compare was done 32 instead of 64. Right. And the key compare was a pointer compare. It was two 64-bit pointers differed from each other by high order bits.
Oh wow! But not low order
bits. High order bits in the same compilation unit. The low order 32 bits were the same. The high order bits were different. And that was the bug.
Which kind of would make sense if the low order bits were 0.
But it's a compilation. I'm doing malloc basically. Somehow I had a malloc span some enormous size or take chunks from different heaps and get, it was a standard arena. I'm growing it by like 64K at a shot. I went back to go grab another one. It gave me 64K the next page over, or the next 4 gigs over. And
exactly.
Exactly. And the hash was just the low bits of the pointer. That's the standard hash for that stuff. I just took low bits and said, your hash, and I reprobe you by something that's prime mod table size. And then I did a full key compare of 32 bits instead of 64. And fine. All right, what else?
By the way, Yasser, if you're in the market, or like if you want to make a strategic move to acquire some users, you could consider looking into targeting the Pokemon Mini. It's a small handheld console. It's pretty niche, but the thing is, so the processor, as I remember, it's an 8-bit architecture with 16-bit ops and 24-bit wide addressing, like 24-bit data bus.
Sounds like an Apple II.
It's a bit like there are some inspirations from a Z80, and it also has a branch delay slot like MIPS. So there's some like funky stuff. And the thing is, there's a really dedicated like small niche hardcore community of people who reverse engineer it, build emulators and stuff. But Now the interesting thing is the only compiler they have, and when I heard that, I swear to God, I almost collapsed. So they don't have the source code for this compiler because it's a proprietary Epson chip.
Oh no.
What they do have is they have a
Proprietary
16-bit.
Epson chip?
Yeah, Epson. Before that, it was
Like the
T-Max or
printer
something.
company?
Yes, they got acquired. Like
They also
the
make
company that owned it
motherboards.
before it.
Oh, okay.
It's like they're making chips? What the hell?
The company that originally created
Gotcha.
this chip is called T-Max or Timex or whatever, and it was a electronic watch company,
Right.
and they created that chip, and later it was acquired by Epson. But yeah, anyways, like the company
Timex
that
was a thing, yes. Okay.
But yeah, so the funny thing is like the compiler, they don't have the source. The only thing they have is a 16-bit DOS binary that they pull from .archive.org. So yeah, and you need to run an emulator to run the compiler for this.
You're generating instructions for an emulated chip from the 80s.
Yeah, but it's funny that you need to like open a 16-bit DOS emulator so you can run the compiler, and this is the only thing they have. And and this compiler is like compiles a proprietary C89 dialect or something. So I don't know. LLVM can target it because it has only 4 registers, I believe. 4 or 5 registers. So LLVM is like it's really difficult to write the backend for it.
Yes.
So like you can actually acquire some like niche users for this, and like you probably can get some good blog posts out of this and waste like 1 year of your life. So yeah, if you're in the market for such an activity, I can also post some links.
I guess in terms of horror stories with proprietary compiler tools, one of the ones I ran into was 7 years ago. Microsoft was all like, "Oh, Clang wants to do PDB stuff. They want to do code view stuff. They want to use their debug format instead of doing all the like GNU side of like debug info. They could at least do the Microsoft side. It'd be great. Now we can put them in our debuggers." They opened up a bunch of details, and they made this repo called like Microsoft PDB or something like that. And they basically said, "Okay, we'll keep filling this in, but right now it's just a repo of like the dumper tool along with some headers." The problem is that the dumper tool doesn't compile, and they said, "Oh, we'll make it compile eventually." It's been 7 years, and they just haven't. And so there's an exe inside of that repo that is like what you're supposed to use to actually like use the parser, and you have some of the code, and then presumably some of it that's just like in Microsoft's like proprietary hands, and they just like never shared it for some reason.
Why are you using this repo?
If you want to, it's like it was the resource for like PDB stuff because at some point it was just not known. And then there's other resources nowadays like the LLVM stuff, but like half the LLVM docs on it are like incomplete. Like if you just open them, they'll just be like an empty page, and you'll just be like, "Oh, that's great." I think I ran into that the other day. Yeah, I'm gonna drop this link.
Yeah.
I opened like this page over here, and I was like, "Oh, great! I love that."
That's the Pokemon.
For reference, it's just
Pokemon
completely
Mini.
blank.
All right. Here's your PDP. Oh, PDB.
Yeah. What is it? Program database or something, I think. It's just like the container. It's just the container format for the debug info.
Well, I open up to an empty page.
Yeah, no, exactly.
Oh, I gotcha.
Yeah, this is one of the links when you search for their docs, though.
There's a nice icon on that. Oh, that's the
Yeah,
LLVM compiler, whatever, some dragon bitey thing.
Mm-hmm.
Fine. Program database. Fine. All right. What else? No one did anything exciting over the holidays. I had COVID twice, so I didn't do anything exciting.
Oh, that sucks.
Yeah. Yes, sir. You are correct. That sucked.
Yeah.
I sent all my kids home on no Christmas. No one came around. We made a big tree. We got a bunch of food. We're going to cook up a storm and then like cancel abort. Suck. And I got a kitten.
Oh, nice.
Control C.
Yeah. Yes, exactly. So maybe in a couple weeks we'll have a post-COVID holiday Christmas. All right, we're running out of stuff. I'm gonna bored if something doesn't happen here. Let's see, I've been doing XTC and I've been doing, well, day and a half, not even on Billion Road Challenge. And then I'm gonna go probably on the weekend do some AA stuff, which I now have I'm doing a cleanup on AA code. And whatever I'm gonna do is simple. God, I got way too much going on now. 15 different things happening at once.
So I was thinking about how Yorick is dumping a bunch of information with each compile to make incremental possible.
Yeah.
I wonder if it makes sense to do something like store all progress and pieces of your compile in something like a SQLite database, where you could really dump a lot of information that is potentially usable and queryable by someone who's curious what happened in their compile.
In the land of C2 doing incremental things, everything that got written out had to have a reader because you had to maintain it for a purpose. And you only wrote out what you knew you needed the reader to look at. So like there's a hard handshake between the reader and the writer.
So you wouldn't want to dump out a table that was just like, here is every symbol that I found when I was parsing everything and the file it was in and the character ranges and what type it was.
Because it didn't matter unless there was something specific about it. Like the reader and the writer had a hard handshake on what it meant to have a dependency. And so it wasn't just every symbol was a dependency. It's just not the case. I had a symbol, I did a lookup, it was a static final const. I'm ignoring your reflection. I took the value, I didn't get a dependency. Suck it up, Buttercup, if you use reflection to change finals. I don't make any promises.
I tried something like what Aaron said on one of my prototypes, and it turned out parsing was like just as fast, if not faster.
I'm sorry, Aaron was saying he wrote a database out to help with incremental compilation, and you said something about parsing, so I'm missing a connection.
He's saying it's easier to just have an Oracle program that rereads the source code and gives you the fact, rather than looking it up in some database somewhere.
If you're just compiling it super fast, the incremental has to be faster than the compile.
Yeah, because what happened was at the time my prototype was very simple, and it was just faster to compile. It was just as fast to compile the program, and it was just like less of a headache to manage like two versions. So I just stuck to the one. I think most of the time went to like just like memory stuff. It was parsing was just really parsing and compiling was really quick.
Just imagine that you're running a highly optimized output code though. So it's not a debug version of things. This is like, I'm doing the Billion Row Challenge. I fucking want the compiler to do something for me here. Now your compiles are not so fast, and you'd love to have an incremental compilation. I quit playing with that thing. Fine.
Like I think it would make more sense if it was already in memory, like if you're doing LSP. But
talking about how you track dependencies. I'm missing.
Oh,
dependencies. Like I've compiled module A, I've compiled module B. I hacked module A. Do I need to recompile module B? In the land of make files, it's timestamps on disk plus pound include headers. And we just assume if you hacked a pound include header, the dependent files had to get recompiled, even if all you did was correct spelling.
That requires you to be explicit. So like one of the bugs I ran across somewhat recently was I had a simple SQLite thing that's like, go run all the migrations in the migration folder before the app starts. And it turns out that it was doing a compile time, read all the migrations in the folder and bake those things into the binary so that it could run the migrations at the beginning. I changed one of those text files. It didn't know it had to recompile because I didn't change the actual source code in any meaningful way.
Right.
And in the land of make, it was like, okay, well, explicitly list all the things that are your dependencies. And if you didn't, then it's your fault.
Right.
And in the land of Rust, it's like, how do I say that this particular source code file is dependent upon reading this particular real file?
Oh, I see.
Make sure it always recompiles correctly.
I see. Right. I don't know. I've done, hand rolled make systems in the past, and you just fold them in, and then it's all easy.
I mean,
Certainly.
even
But yeah, it's an interesting game of if I want to have everything discovered the way Go does, where I just say go build main.go and it reads all the imports and figures out all the dependencies and runs down the chain so I don't have to make a make file.
Yeah.
Then you need some way in the syntax to say, and right here, be dependent upon this other file that you read at build time.
At build time. Yeah. Any compiler on the planet does that. Everybody, C2 internally, depends on the x86 machine description file or the ARM description file or fucking Itanium description file. And those change and they're not C source code. So, yeah, you had to have a dependency that was not obvious. I don't know how you would do that you could do that in your syntax of your language, somehow have I don't know how to do that. No, I don't. I don't know how to do that. I would love to have it do it so that you could do exactly what you said. You do some sort of main go, he reads top
and
down.
now read this file.
Yeah, and then I depend on the output of this other file. And the output of the other thing is a machine description processor who then in turn reads a machine description file, hacks in the file, describing new x86 encodings, hacks in the machine description parser to take advantage of that. They all produce out a new C file or C++ file that contains the hardware descriptions or hardware execution stuff you're going to do at compile time that when executed emit out binary bits, for instance, encodings and shit like that. But you depended upon the runtime of the compiler, depended upon another piece of C code that was completely auto-generated by a tool that depended on a machine description format. The tool could change, his source code could change, the machine description can change, any of those could change. It was all easy in make because you just pointed them out and say A depends B, C, B, D, whatever.
Yeah, the advantage of make is you just say what your dependencies are. The disadvantage of make is you have to say what your dependencies are.
Yeah, exactly. Yeah. I'm trying to think of a good way to do that. This file I have in C, he depends on this other file that's written in C. You go to that file, somehow that file says, I depend on this machine description builder that's going to build me. I'm totally auto-generated. If you don't have that file, you can't discover it or figure out how to auto-generate it. But if I can say in the file, in the comment, in the header, I am a machine-generated file, I get generated via this, then your discovery process could roll backwards and keep discovering things.
In the same way that newer languages combined the CPP files with the header files and was like, no, the code and the headers should live in the same file. I want the code, the headers, and the dependency graph to live in the same file.
Somehow,
and each file just tells me what its dependencies are.
Yeah.
That shouldn't be in the make file. That should be in the source file, I think.
Yes.
In making a new language, at least.
All right. I will ponder on that one when I'm next screwing with AA. Not that I'm likely to hack it right now.
I'm just wondering, which languages can read files during the build time?
Well, C can.
Anything with macros?
Yeah.
Zig's got it, even though it doesn't technically have macros, because you can ask to read a file. My phone's dying.
I know XTC's doing it.
Yeah, I know that Embed in C does it, and I heard of Zig doing something like that, but I don't actually know specifics.
But yeah, you really do want syntax for, and now read this file into a byte array and include that in the binary.
Yep.
Put a pound in front of the path, and that represents the bytes of the file, or a string in front of a $sign in front of the path, and that represents the string that's in the file. Or you can just say file f equals and put the path of the file, and that represents the file at runtime. But it's actually coming from the, think about an assembly. It's as if you put a db and then db isn't defined bytes, and then just put all the bytes of the file in with the metadata, like name of file, creation time, modified time. And then at runtime, we just create a file object wrapped around that metadata.
Gotcha.
Yeah, I think that's a feature that should be in new languages. Like, it's convenient.
I think that's a good idea. Yeah.
There's a reason I did it, which is when we designed it, which is in Java, at least 500 times I've written the code to read a file just because I needed it at compile time to be in the jar. and then loaded in a variable at runtime. And it's like, why do I have this code all over the frickin' place, right? Or why do I have 10 helper functions to do this when I could just have the compiler do it for me? And then there's no code, there's no exception that could happen because it's already done, right?
Yeah. Yeah. Yeah, it was like icons for web development crap and
Icons, the default font. Whenever I start a program, it's like I couldn't find my default font, therefore I can't run. You're like, what?
Yeah, I think Cliff knows all about it because this week I actually published a utility that would show you all the files and directories and whatnot that are stuffed inside a. See if I can find that. It's a paste bin link, right? Yeah, here it is. Found it. I'll stick it in the chat.
doc.
Yeah, I'll stick it in the doc. Doc.
Go find it here, yeah.
But this is the output from one of the tests that has an entire directory embedded in it. So you can actually see that the module contains 23 directories and 249 files. So basically when you say like directory D equals in a path, at runtime, you get a directory object. It's just that it was snapshotted by the compiler and stuck into the
thing,
module.
Yeah. That seems like the right thing to do to me.
And it's really handy for things like doing anything on the web where you have some images or some CSS or whatever. Like they're changed at compile time and then then they're deployed with the app. So it just grabs them and away you go.
So do you allow writing? Is it read only or?
It's read only.
It's read only. Okay.
Yep.
You mean non-persistent in place writing, but as soon as you try to append, you have, I don't know, you could do it, I suppose, but it doesn't back by disk anywhere, so it's all thrown.
Yeah, I mean you just whip up because file system is a
right
user implementable object. You could have a file system backed by another file system.
Yeah.
Keeps the diffs in memory and throws it away. So ephemeral, I think, is the term.
Ephemeral file system for it. Yeah. Okay.
Just clone it to a cow thing and keep going.
Yeah, exactly. Something happened there. Oh, let's see. Simon, you were going to say something a while ago. I was wondering if you had a status update.
Oh, I just have a short update on my struggle with equality and identity. And I recently saw a Rust RFC, which was so bad that it motivated me to finally get all the stuff implemented in my language correctly. Let me see if I can share. I'm not sure. I just have Zoom open in the browser.
Hang on.
Let me see.
So see if you can share.
Let's select window, screen. Okay, let's try this. Is this working?
Yeah, something's happening.
Oh, nice.
Yeah, so give it a second. It's half done. I have a mostly page.
No. What is it? What is it showing?
Well, it has like your empty desktop, top left.
It has a plus on the left.
Yeah, new tab and a plus. Yeah, pretty empty.
Oh, damn.
I don't know what you're sharing, but maybe you're not sharing what you intended to.
Let's.
Looked like an empty IDE.
Yeah.
Let's try it again. All right.
Nope, empty IDE again.
Yeah.
It's actually the JetBrains toolbox. At least.
Oh.
I believe it is, considering the tab on the bottom.
Showing something. Oh well, sorry about that. It's I can't get it to work.
Is that the crisis you're dealing with?
Yeah, it's how do I abort it?
Language, it's all white space.
Yes.
Oh well. Yeah, there was a maybe I can just abbreviate a bit. So there was a Rust RFC concerning a constants in pattern matching, and they had this. They basically tried to formulate what they were actually doing in the language, and they had this problem. They of course wanted to be able to match on specific low float values, and then figured out that like their standard float equality wasn't the one they actually wanted to use. And so now the proposal is to add like another structural partial eq underneath partial eq that kind of allows matching on floats because it's not a eq that float doesn't implement as a trait. But on the other side, they back out matching on specific float values immediately because actually the partial eq implementation they inheriting from they are inheriting by being a structural partial eq is not the behavior they want, and it's super weird. It's like it's complicated. It doesn't do the thing it's meant to do, and it's just bad.
They're trying to do float comparisons. I don't understand what's going on here.
So wait, there's a trait like eq like equal that's for like if there's a like there's equality, partial equality, but then you mentioned structural partial eq. What is that?
Yeah, that's the thing they're proposing. They basically want to add another trait below partial eq because using partial eq has worked so well in the past, especially adding new things below that.
I found the relevant Reddit comment I'll throw into the link.
Yeah, they're doubling down on like on past mistakes, and it kind of motivated me to get my house in order, so to speak. And I had some interesting revelations regarding how hashing needs to work, because basically if I have like a method called contains that operates on saying, well, the value I'm checking should either be identical or equal, then the hash function operating on that value better compute hash values that are consistent with that requirement. And for floating point values in that specific case, it means we are basically just throwing away the sign bit because we want to compare 0 and -0 the same, and it's walking a fine line, but I think I've managed to do it, and things work correctly now, and maybe I can just share
equals and hash code go together, so if you redefine one, you have to couple it with the other.
Yeah, and yeah, and in addition to that, yeah, it's also in my case, in my language case, it's more closely operating with identity, but I had to weaken hash technically so that it doesn't disagree with equality. Because with like equality, 0 and -0 are equal, so having a hash code that distinguishes 0 and -0 would not work. So that means the hash code is slightly weaker than it could be, but at least it's correct.
Doing something weird with nans too?
It's the behavior falls out naturally. So saying I have this contains function, and contains is defined as equal, is defined as identical or equal. which means if I ask, does my list of nans contain a nan, I get true because one nan is identical to the nan I'm asking for, even if it's not equal. And it works for -0 compared to 0, and all the weird corner cases are basically modeled to work. And yeah, that's basically the language. The standard library has now a consistent contains implementation that operates on identical or equal, and the standard library now has an includes function that only operates on is this identical, and basically you have all your data structure. You can ask them whether it contains something, whether it includes something, and it will always return the correct value regardless of whether
So
it's a
you
float or not,
put-
or an array or an option or something.
You put that on the word contains as opposed to passing in a comparator function that does a contains or does an equals or does whatever flavor I want.
Yeah, I mean, nobody. We could design it like this, but nobody will ever do it. If you're if we are realistic, they will do something that seems to be correct and might work, and then it will obviously be broken for floats or for some other.
So does this mean that you have to
case.
define multiple equals for each object or for each type?
You have a contains and you have a includes and a.
Yeah,
all
I mean, it depends. It's like if you have a data structure, it might make sense to offer both. So you can ask, well, does my data structure include exactly 0.0, and then you get a true and a false depending on whether 0.0 is in there, and exactly 0.0 on like not -0.0, or you can do, well, things that are technically the same, it should just work. So they can use contains and ask, well, is there something 0-like in there? And if there's a -0, they will still get true. And I'll just add the link to the link section, and yeah, I have like the corresponding issue I worked on in my repo, and yeah, so I'm pretty happy with how that worked out. I'm very interested in whether Rust will will go through with that proposal, because it's like, I mean, it's like, it's not very good, but it's also not breaking new things. It's just doubling down on things that haven't worked in the past already. So who cares?
Yeah. Yeah, it's people torturing themselves over nans and -0s. It's like useful for the numerical crowd, and for everyone else, they're like, they break all my whatever properties that I expect. Fine. Well, what else? We're very slow today, but I guess it's all New Year's stuff.
I put putting the link to the RFC in the docs. I think the RFC describes it quite well. Like how when you are in a match statements and you do a pattern matching, you have different semantics, different ways of like, yeah.
Okay.
I think I added the link already.
All right, then sorry.
No.
Another good example where people actually want decimals but are using binary floating points.
Keep the link. I think it's a different one. It's
yeah, interesting.
It's fine.
So I had a quick question for people here. So my current the thing I'm currently occupied with is making assembly a bit more ergonomic to write in my language. I have like decent like editor support. I have nice highlighting and stuff like that. And I mean, it feels good, and I want to maybe improve improve some things around like reducing redundancy and repetition. In some assemblers, they have like these macros where you can maybe you have a block of code, you want to repeat it X times, and then maybe iterate through certain registers or something. Or just have some way of doing macros in a nice way. And I figured maybe I can improve a bit on that, maybe use for loops or like the common structural, like the common control flow things that we have in higher level languages, and maybe map that a bit to assembly to create like this macro kind of feel. But while doing it, I was very curious if any of you have experience writing assembly in an IDE, and if there is an IDE I should maybe take a look at, or like what the most ideal, like
I have
maybe
tons and tons of assembly writing experience. I don't know if you want to hear it though.
yeah, maybe could you elaborate a bit, like what is the most ideal, most productive workflow?
Oh yeah,
or
that
like
was
what do you look for from an editor that really wants to help you out, like genuinely?
Right. So step one is that all assembly languages I've ever looked at were crap, and I throw them all away. And when doing the port hotspot, but several other projects, I wrote my own assembler with my own syntax that would run in the high-level language I'm currently implementing C, C++, whatever, look like assembly of my favorite syntax, and emit the assembly out as well. Now I'm writing in C code with a DSL that looks like assembly. I get all the help from the IDE on doing a C code, Java code, whatever. My syntax is identical across a wide range of hardware targets because I've remapped all the Intel move ops to just loads with different addressing modes or not. And I renamed all their REX, RBX, REX, blah, blah, blah to R0, 1, 2, 3, 4, 5, or whatever. You get some canonicalization. You want a macro to expand out in counts of an instruction? Well, you write a for loop in C. And then you write the load and whatever. You want to have a GC metadata at a particular point, you flip out to the C code and say, oh, add GC metadata here. You need to have a cache line to line instruction sequence so you can hardware patch it with self-modifying code. Well, you put in I'm inserting an inline cache here. Inside the inline cache, he says, and now go get the PC, go do mod insertion to round up to the proper alignment boundaries and blah, blah, blah. All that support kind of falls out in the wash. So yeah, I said, I'm not writing your assembly. I'm writing my assembly. It's actually C code. It looks like assembly. I comment it like it's assembly. I fill it out like assembly. You do the right thing there. Hand in hand with that is I would do a mix of hand rolled into automatic register allocation. So if I named a register, I wanted REX, I got REX. If I use another variant of it that I passed a register in on and I told the allocator to use or not use, I would mark explicit lifetimes with basically try finalies or try with resources kind of effects. And then it wasn't a great register allocator, but it would let me do stupid, easy stack counting, and he would just tell me if he ran out of registers. But he would stack registers in and out through all the macros. And so I could write assembly that I didn't do register allocation for most of it. And I could get hand register allocated where I wanted it.
I have a question. Could you maybe share a screen and just write a few lines of such code as an example, so I understand better how that would look like?
Yeah. Let me bring
Yeah,
up
this is basically the style that I end up using, where it's like step one in writing good assembly is to write your own macro assembler.
Yeah.
And you just like do that in whatever your favorite language is, basically.
Interesting.
I know that what's his name, Mike Paul from Luagit, he did Dynasm, where he like had some like meta program that you could write on top of C to do assembly code generation that like interleaved with the C code. And let me send a picture of that.
Oh, wow.
Let me just send a link.
Wait, so is there a chance that maybe like particularly enthusiastic assembly programmers would not even like my syntax, and end up writing their own macro assembler. So
Oh,
maybe,
absolutely.
so then what I'm doing might be pointless.
I imagine most people who write assembly are gonna like have their own tools for it, just because like assemblers suck, and there's no way like there's no way they just put up with that.
Interesting. All right, that's very good to know.
Believe you'd say that, Yasser.
Yeah, to be fair, they are assembler people, so maybe like they just have a different kind of tolerance. Here, no, whoops, wrong link. Here's the link. There you go. Yeah, so I placed the Dynasm link into the chat.
Thanks.
I'm writing something like I'm writing here, you know.
I see.
So the addressing mode might look something like that. And, you know, basically somewhere in the world, I said I have an assembler object that lets me collect the bytes, throw my metadata in, relocate it when I'm going to run it, have an executable entry point, yada, yada. For me in hotspot lands, it gets copied into the code cache after a while, and it grows dynamically, and I don't care about my size, so it's all the bits are being thrown in somewhere. Then there's loads and store ops and adds and moves and whatever. The double underscore was just the DSL to move you from C code to assembly, but you could have whatever your language allows for a entry point for that. I did labels a couple different ways. I did auto-generating register allocation a couple different ways. So here I'm using hard macros for RAX, or just somewhere in the universe. There's a, you know, so I said import, you know, ASM somewhere, and that picks up, or import static, you know, and that picks up RAX. And RAX is a constant. It's the register allocations binary encoding at 0, 1, 2, 3, whatever. And then the load op just knows he's getting a small register constant. He deals with it. If I'm going to have a macro I'm going to inline, then somewhere else in the world, he's got a, you know, he'll take a register, and I don't know what that register is. And then in here, I'll be, you know, store R, comma 17 or whatever it's going to be. And they can write these things out, and they just expand out. As you execute the C code, he just piles out the corresponding assembly code. Except I was pointing, not even assembly, of course, I'm spitting out bits. It's encodings. And this was for racks, and racks is for MIPS, and this is for Itanium ARM, Itanium, and x86, and Spark, and whatever other guys the same load ops rolled around.
It's
Spark
cool.
picked up a delay slot that other guys didn't have. It had a delay op. Stuff like that. You had special instructions for some guys. It was all very canonicalized for the 99% case. Everyone does loads and stores and adds and some tracks. And then people have weird ops for some things. You know, no one else does a push and a pop except x86. I had lots of those.
Great, thanks. Yeah, then that is that's actually good. That's actually good to know. I had no idea that. I mean, I did think that some people would be writing their own either DSL or macro assembler, but okay, it's already 2 out of 9. So
if you go to the hotspot open source, OpenJDK open source code base, you can hunt your way down to see miles and miles of this kind of assembly written. There's absolutely gob tons of it.
Like that, like actually in such a DSL.
Yeah. Oh yeah. Actually,
okay.
It's not me. I didn't start this. Somebody else did it, and I thought that was a good idea. So I was like, desktop, Dropbox, program. Hang on. Hotspot. Here's version 7 source. CPU, Spark, VM. Yeah. Okay. Probably don't want to see that. Really? Here you go. Oh yeah. Here's some tons of it. Let me share again. Share. Boom, boom. So here I am with C code, void interpreter, C++, signature handler generator. Create some day night arguments, throws down some temps. If you're 64, if you're 32-bit, jam down load or load X locals with 2 arguments instead of 1. Here's passive flow. This is a signature handler. He's trying to build from a call site trampoline that moves arguments from the native C calling convention to the Java calling convention or back and forth. So the Spark in particular calling convention was a little egregious if you're trying to do var args and pass values in floats versus ints. And the Java version was strongly typed, never passed floats and int registers to honor var args. So there was always a shuffle. And so you get other kinds of shuffle. Here's a conditional, I'm either inserting a test or I have some add conditional CC with G0 is always 0 on a Spark. So that's like a +1 on top of whatever other thing happened. Branch, there's your delay slot syntax. I highlighted it. Bind a label. That was what I'm trying to remember how you bind a label. So you created a label in C code. You could call it here. It's passed in as something to the branch X, not 0 true, and then you bind and so on and so forth. Flush is a Spark register window flushing instruction.
Is that like now specifically for Spark everything, or I mean, I saw some if that's here, but
yeah,
is this portable?
This is the Spark machine code. So in the same directory, I'm in Spark. Let me go up to x86. Let's go find interpreter generator. No, was that interpreter signature or something? One of these things will be very similar. I'll grab something nearby. It won't be the same thing. Generate slow. So here's the x86 version. He's got loads in it. When I went to Azul, I just moved all the x86 moves to loads.
And that's wild. There's a switch statement, but an interleaved with assembly. That's
oh
pretty
yeah,
cool.
Yeah. It depends on what you're generating. So this switch says on a 0, 1, or a 2 or a break, I'm going to emit this, that, or the other. And what is I here? If I can find where I got defined. Oh, how many arguments am I passing to registers? So I'm going to make a version of this that's got 1, 2, or 3 args passed in registers, and the rest are going to be pulled from the stack. And he's emitting multiple variants of the signature header. Yeah, generate slow signature handler. So he's doing signature handler shuffling games. This piece of code. Stub generators, so some more stub routine. One of these will have more obvious sets of things.
I showed an example of like Turbofan doing a similar thing because I presumably they're just inspired, but yeah, they have like the similar like __ like macro number style.
You got one going now. I can quit share.
Yeah, I sent a link in the docs.
I'm trying to decide if I should quit share here and go let you share. You put in a Turbofan. Yeah, right. Okay. See what they got here. I'm bringing up. I'm not showing though. I got chat in the way. Yes. Oh, that's just almost surely. It's the same guys. Robert Griesmer did a bunch of the stuff originally. He had a couple of guys. His original the original Self crowd that Sun hired to go make hotspot instead of Self walked in with this technology. I don't claim it at all, and I thought it was a really good idea. And I cleaned it up a bunch as I moved around to Azul and other projects I did. But I know Grismer went to Google, did Dart maybe, and then on to Go or something. So I can totally imagine it shows up in Turbofan.
Interesting. So you can basically, I mean, you have on the one hand explicit register allocation, but also you can allocate like integers. And just you have the mix of automatic and manual.
Yes, you have a mix of automatic and manual.
I guess there could be tooling that helps you figure out like what the compiler decides to allocate, like which register it decides to allocate. Like
When
when
you
you
do-
hover over it or something, maybe it could show you.
Yeah, I don't know the V8 code here, but when you do automatic management, it's usually the case that you have a pool and you just pull from the pool until you run out, and you have to have a return back to the pool. Or at least that's how I was doing it. In the land of hotspot, originally, you would manually say, I'm using this register, and track yourself which ones were free and which ones were not free, as you nested in a tree fashion, eating registers as you went down the tree. And then you just made a function call forwards. I gave you this or that or whatever. The leaf routines kept called from all over the place and took different register arguments. And then you had to manually know they were free in your head. Later, I moved to Azul. I want to say I hacked a bunch more things where I got a little smarter about it, where I would just have a list of pool and have a try with resources flavor to recover a tree-like recovery of a register number, and then you would just pull from the pool again. That's interesting. That looks like somebody doing profile data to decide to implement one thing or another. But the add quick input sounds a lot like go get a register. I.input register 0. That smells like I'm getting a register from a pool. I don't know. But that could be.
Yeah, my understanding is that, so like at this point the register allocators run, so the instructions all have like registers assigned to them at this point, and they just grab from there.
There's no register allocator. This is assembly code. So you would otherwise hand register allocate.
Well, so in this case, the idea is like, so if you have instruction and you have input register, I think it's like the instruction was generated already, and then we have like a higher level idea of what it looks like. We say this is where the register allocation needs to go. We have some inputs, some outputs, and then it just like grabs from there.
No, this is not C2 doing register allocation. This is hand roll assembly. Somebody calls code generator or table switch. I've highlighted it.
Yeah.
Okay, at this time, they have a pointer to some place they're going to jam instructions, and they have some pool of available instructions. So they reach into their pool and they say, get me a register. Knowing that in the land of the assembly code they're at, all the following registers are always free unless they're being consumed already by whatever they're doing. So I'm probably looking at, no, this is V8, then I don't know. If this was C1, you would have a register allocator involved. If this is V8, I don't know. So I'm going to guess
I believe they do like a register allocator before this stage that has all these constraints already written into it.
It's hard for me to say. It could be that they've said when I emit an assembler arch table switch,
Yeah.
I know I need 2 registers to work with. I need one to go do some math on the index. I need one to shuffle whatever fuck else thing I need to do. So they decided they needed 2 registers. They allocated them. And then when they went into this point here and they go grab from I.input register 0, that said, oh, I got allocated already. I've pulled the register. That could be how they did it. When I'm doing hotspot and I'm in hand rolling assembly, I've usually entered an assembly stub in a mode where I have stacked all my registers, and most of them are free. I now go to the assembler and I tell it, hey, the following registers are free or not, and usually it's the default set, so I don't say anything, and it gets the default set of free because he stacked them already. Now I walk through and I just say, give me a register. And he says, the first one free is RAX, here you go. And then it's free until I walk off the end of the function where I free the register. So that's the C++ destructor try with resources, reclaiming the register. Inside here, I call some other function, get label of blah, blah, blah. Here's an addressing mode for you, and get label internally might need a register. I don't know. So then he says, oh, register allocator, give me a register. And he says, well, RBX is the next free. Here you go. But I'm done with get label, so RBX is back to being free again, but RAX is still in use, as a for instance. And down the line you go, K scratch register. Where did that came from? Well, he probably has it pre-cooked as in all of these functions, we know that no one is allowed to touch RSI because whatever, I'm going to claim it's scratch. And you know, if I look through here right now, I'm seeing only a handful of registers concurrently in use, 2 or 3. So he probably grabbed one. He's got this, and he's got the input, and he's got the scratch. And whether or not get label internally, no, that's going to be the label for where he's going to jump to, which is part of his assembly language syntax. It's not hotspots, it's V8s. Someone in the universe on the table switch has probably a set of labels, and he knows he needs to go grab the first label and then grab the next and the next and the next or something. And he walks down the line emitting tests and jumps to, okay, this is a binary search. So compare long, jump above equal. He's doing a binary search. So it's a binary stacked table. And he probably has switches for each of the targets that he's running to, and so on and so forth.
Yeah.
I have two questions about this. First, I guess in such a case, like for such a particular language, the compiler should ideally like emit either warnings or compiler errors if you're spilling something, right? Like
Yeah,
if you
for
don't have
me,
any...
it was always, so in the land of hotspot, if you blew it, you blew it. And those were bugs, and you had to go sit down in the debugger and step through the code emission, you found the bug. In the land of Azul flavored version, I counted them, and then if I ran out, I just blew up. And usually I blew up because somebody had a loop where they failed to unstack every iteration on the loop, and so they just ate registers indefinitely until it ran out. And it was never going to work. No possible allocation was going to happen there. But yeah, you just stacked and unstacked, and you counted, and if you ran out, you blew up.
And another thing is, like, should it be possible to like allocate things that don't fit into registers, like maybe structs that are larger than register size?
I didn't do anything that had a memory identity with special handling. I would certainly take things that I knew were structs that I understood the shape of and unpack them into registers, fool around, store them back in, maybe if I had to write updates back down. It was quite common to say I had a pointer to a Java internal, hotspot internal capital K class object, which was a C++ variant of a standard class header, which had a known fixed layout for where to find things like the vtable, the beginning of the vtable, the GC bits for how do I describe where the fields are and which ones are pointed or not, and a bunch of things that you assembly language wanted to get right away. So you could tell it, I got past a Java object. I loaded a class pointer. Now I have a class pointer register. Load at plus X offset to go, I treat it like an assembly language version of go load a field.
That's cool. That makes sense, right? If you have a pointer to a struct and then you want to load individual places, like fields that fit into registers, that's useful.
And I would have the names of the struct fields in the assembly language directly, so that it would, and in fact, for a lot of them, you just have a special wrapper, so it would look even more like it. It would say, I have a class in pointer 0, and I want the field blah, and so I would have get class, get mark, get the lock bits out of the class, because are you locked or not? Well, that's a load shift compare blah, blah, blah. And then the lock bits get a little bit more free to fool around. And you could change the header and said, I want more bits for the GC and less bits for hash so I can have a bit for the lock or whatever the hell it was going to be. So a lot of those things had special functions like dcheck NE. A lot of these also had asserts baked in. So you do these things that have these whatever, and internally it expanded out to some large, complicated, arc selects got conditional moves only on some hardware probably, and something else on some other. And you had a bug. So under debug builds in your handhold assembly, you would emit assembly for doing an assert. And then, yank that when you were not doing debug builds. Finish frame. Here's a lot of things where I say frame arrow, align callee save register slots. Almost surely this would do some sort of mask and add on the stack pointer somewhere in the universe. And count however many saves FP came from. I got this from the callee saved FP registers. And if it's not empty, and only if it's not empty, then I get the count of them, and then I do blah, 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 whatever, fine. So you use a lot of metadata hacking with your assembly things. Yeah, PC base, go ask the allocator the current PC offset. Push Cuik, RVP, move it to SPs. I never used RP. I kept RP. Intel had too few registers. I kept RVP. I didn't use it. Fine. If I'm emitting WebAssembly, else if I'm emitting this prologue, else do the stub prologue. Yeah, okay. It's not hotspot, but by God, the hotspot looks like this in a lot of places. Go, like I said, I'll show you the OpenJDK code. Go find the OpenJDK code. You get tons and tons of this kind of stuff.
I'll definitely check it out. That's I mean, on the one hand, it's I'm a bit surprised, honestly, but also relieved because I mean, I think there's still some room for improvement there. I mean, it is in the end. I mean,
20 years ago, this was mind-boggling.
yeah, I mean,
25 years ago, this was
right.
amazing shit. Here's a comment they put in the code, and I totally had those too. Yeah. And if you took the Azul disassembler, it would unassemble to look like this code, including the comments and all the typings and stuff. So it was, I wouldn't say it was a bijection, but you clearly could read the assembly you wrote from the Azul debugger, which was the online, on the fly, opened a web HTTP port to the running JVM and go ask it shit about where the current program counter is and what it's doing, your hotspots. You get all this stuff disassembled looking like this. Move quick, add quick, comp quick, jump equals, blah, 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 however it was done. All right, I'm going to stop you. But the chat lit up hugely. Do I care? Do I want to read the chat? They're like huge. Oh my God. Okay. This is somebody talking to Simon about what's going on with your language. I like okay and error instead of pass and fail, but I get why you might want pass and fail. 0.0 divided by 0.0. Do I want to box it? I don't want to even know. Java puzzlers. Yes. Fine. Okay. Shit, it goes on. I'm done. I'll read chat in a minute. Holy crap.
About equality testing.
Yes, of 0.0. Fortunately, I just had to implement the IEEE spec. I didn't have to debate semantics.
Well, it's a question of...
The problem is that a lot of people who haven't read the spec also love to debate semantics.
Debate semantics, yeah.
Like, not against you, Cameron. I was speaking in general. But, yeah, it's kind of like an annoying thing of having to say to people like, read the spec. There is literally a chapter in there that describes how floating point has a total order and how you can check for identity. Just read the damn spec. And people just don't read the spec and try to argue about their opinion of how the spec is worded.
If you want people to read the spec, post a link to the spec on Reddit, but then put the content of it in the first comment under the post, and people are going to read that. They're never going to click the link, but they will read the first comment on the post.
Yeah, but then I think it's like if I have to, it's like I don't need an explanation. I know what the spec says because I read it. I'm not profiting from making other people read the spec. I can just ignore them if they're wrong. So like I'm not losing anything. And if they can't do the effort of clicking on a link or reading a PDF on their own, then maybe their opinion is just as well considered as the effort they put into it. So maybe
that was very well stated.
I don't know. I feel called out.
I watched you dance around those words. I think you did a good job.
That's pure luck.
It's worth what you paid for it.
Yeah, I mean, this Cameron and me had a discussion regarding my older blog post on equality and identity, and I think Cameron has a point that some of the parts are not fitting together very well, and there's some kind of connection missing, and an example.
It may sound insulting, but I think I don't think this blog one measures up to the rest of yours because you usually are very complete, and this one took some shortcuts.
That's totally possible. I mean, it's like 6 years old. I mean,
yeah.
And I think it was never reworked or something. It's like it has been reworked, but okay, yeah. But yeah, usually it's like it needs a ton of rework and getting it from a shape where I understand it to a shape where also other people understand what I'm talking about. And so that's certainly good feedback.
The other thing is that, you know, quality is one of those things where there is no right answer. So you're not trying to find the right answer. You're trying to find the answer that developers won't realize you did something because they don't have to think about it, because for whatever reason, whatever choice you made ended up working for what they're trying to do, right? And so because there's no right answer, it means sooner or later some developer is going to fall off the cliff and hate you and curse you and whatever else, right? The question is does it happen, you know, 7 times a day like it does for me in Java? Does it happen, you know, 100 times a day like it does for me in C++? You know, or like so what's the likelihood of finding those cases where it's not out of the box doing exactly what the developer would want it to magically do for that one little special use case of theirs, right?
Yeah. I mean, in the end, it's like interfaces are cheap. We could have like 20 different interfaces for 20 different kinds of equality or something. But at least in my like where I'm working on, I found it that like having the two interfaces that ask, is this identical and is this equal? Kind of like I don't want, it's like from my perspective, I need at least 2. If other people need more, that's totally fine. I'd love to only need 1, but I don't think it's possible because I mean we have like floating points. We already have 2 definitions of like sameness and order and stuff, and like all the people who thought they were smart in their language and came up with some shortcuts, they never worked out. So yeah, but the thing I really think
triple equals didn't work out.
Sorry,
triple equals didn't work out is what he asked.
Oh, I think I wouldn't really. I mean, it depends on the language what it does exactly, but I wouldn't call it a shortcut if the triple equals implements like the implements the total order from the floating point spec.
Yeah.
Just like the double equals implements the partial order from the triple E spec. That would probably be fine. I mean, like people saying, yeah, we're doing a floating point things, but like not a number compares equal to not a number. So we are fixing the special case and stuff. And I mean, or like dividing by wrong example, or other things where they say, yeah, well, we do this shortcut, and they write a lot of text about why they're doing it and why they have thought about it, and it never feels like it's working out. It's also like I think there are like division by 0 for integers, where some languages say, well, we just return 0, and yeah, it's I think it's kind of not as bad as some of the shortcuts people take for floating point, but yeah, mixed feelings about it.
Well, I think with floating point in specific, you want your floating point type to expose all of the 754 defined operations explicitly, in addition to whatever you do for equality by default.
Yep.
Because, you know.
Yeah, from my perspective, it's like, or from the thing I've built it is saying, well, we have this thing called identity that asks whether something is identical, and it's like this hard machine truth of, are these bits in these registers the same or not? And it's also a trait that in my language cannot be implemented by a user, but a type basically gets handed this identity implementation by the runtime, and the user cannot influence the semantics. And that's like in opposite to the equality trait, where it basically says it's meant for the user to implement in a way that makes it act like the equality in his or her domain are supposed to act. And I think that's kind of the thing also that's working really well, because if for floating points, because if you say, well, this floating point type I have in my standard library, I'm not looking at it like it's a type I wrote, but it's like a type that the IEEE standards committee wrote for me, including all the semantics and everything, and I just treat this floating point type in my library just like it came from somewhere external, and these external people defined how the equality trait is implemented, and the only thing my language needs to do is to respect that the author of this floating point type defined equality the way he or she wanted, and my language will work to basically obey that. And that's basically the magic behind having stuff like contains working, because it's I say, well, contains checks identity or equality, and that's kind of what people expect. And if they want to have like a harder machine truth of containers, they have a different method. And yeah, people have to think what they want, which one they want to have. But I think it's a small price to pay. Sorry,
I'm gonna start wrapping it up. People are dropping off, and
Right.
we're running past our 2-hour mark, so it's getting time.
Thanks.
All right. It was a good talk, everybody, and we'll see people next week. Bye-bye.
See you guys.
Goodbye.